Welcome to calculus.
After many years of combining like terms to make one expression, now we get to take it all apart.
On this episode, Stevenson will demonstrate
Here's our first example of how we can create a linearization of a given curve at a specific point and use it to approximate. So here's our question. Suppose f of x is this polynomial. Find the linearization, they're calling it L of x, of f at x equals 2. Use the linearization at this point, x equals 2, to approximate the linearization approximated at 2.1. And then compare your linearization of 2.1 with the actual function evaluated there. So we actually have the original function. So all we're doing in this example is I want to demonstrate to you just the process of finding the linearization and how it compares to the actual value. So with this, what we need to know is what is our function evaluated at our particular value, x equals 2. We need to know the derivative at x equals 2, and then we're going to set up our approximation or our linearization. So what I'm going to do right here is I'm going to do the derivative, and then I'm going to evaluate it at 2. Next, I'm going to actually evaluate my function at 2. Now I have my slope and my point, so I can create my linearization. Remember, the linearization is just the equation of the tangent line to our curve at this particular point, x equals 2. So this is my linearization. So now what I'm going to do is I'm going to use this to approximate what the function could be evaluated at 2.1. According to my linearization, I'm getting approximately 8. So what I'm going to do now is actually plug it into my original and see what I get. So here's the actual function evaluated at 2.1, so it's 8.061, and you can see our linearization gave us 8. So it's a pretty close approximation there. So this is generally the idea here, is we're using the equation of the tangent line to approximate the actual curve. And again, the closer you are to the actual point itself that you use to make the tangent line, the better your approximation is. For example, if this was like 2.5 or 3, then these two numbers would be much different and they would be farther apart in their accuracy.